Models with production. In this section, we derive convex programs for certain economies that generalize the exchange model by including constant returns to scale technologies. The idea for deriving these convex programs are built on the ones developed for exchange economies with special utility functions. In a constant returns economy M, there are L producers as well as the M consumers and N goods for the exchange model. The K producer is equipped with a technology that is capable of producing some good, say little OK, using the N goods as input. The technology is specified by a concave function Fk, which maps from the domain R plus to the N to the range R plus that is assumed to be homogeneous of degree 1. The interpretation is that given quantity Zj, which is greater than or equals to 0 of good J, for 1 less than or equals to J less than or equals to N, the technology can produce up to Fk of Z1, Z2, Z3 until Zn units of a good little OK. At a given price vector pi equals to pi 1, pi 2, pi 3 until pi n in R plus to the n, the producer will choose a technologically feasible production plan that maximizes her profit. That is, she will choose Z1, Z2, Z3 until Zn, which is greater than or equal to 0, that maximizes the profit pi little OK Fk of Z1, Z2, Z3 until Zn minus the summations of pi j times Zj summing with index j starting from 1 to n. Now, if there is a choice of a non-negative Z1, Z2, Z3 until Zn such that pi little OK times Fk of Z1, Z2, Z3 until Zn minus the summations of pi j Zj summing with index j starting from 1 to n, which is greater than 0, then using inputs alpha times Z1, alpha times Z2, and so on until alpha times Zn, for alpha greater than 1, she can obtain a profit of pi little OK times Fk of alpha Z1, alpha Z2, and so on until alpha Zn, minus the summations of pi j times alpha Zj, summing with index j starting from 1 to n, which is equals to alpha times pi little OK times Fk of Z1, Z2, Z3 until Zn minus the summations of pi j Zj with index j starting from 1 to n. Thus, a profit maximizing plan is not defined in this case. A profit maximizing plan is defined if and only if no feasible plan can make a strictly positive profit. In such a case, a profit maximization plan is one that makes zero profit. In particular, the trivial choice Zj equals to 0 for 1 less than or equals to J less than or equals to N, for which Fk of Z1, Z2, Z3 until Zn equals to 0, is always a profit maximizing plan whenever profit maximization is well defined. It is useful to restate the above in terms of the unit cost function Ck, which maps from R plus to the n to R plus. This is defined at any given price vector, pi 1, pi 2, pi 3 until pi n, in R plus to the n to be the minimum cost for producing 1 unit of good little OK. That is, Ck of pi equals to the minima chosen between the summations of pi j Zj, summing with index j starting from 1 to n, such that every Zj is greater than or equals to 0, and the Fk of Z1, Z2, Z3 until Zj is greater than or equals to 1. If pi little OK is greater than Ck of pi, then profit maximization is undefined. If pi little OK is less than Ck of pi, then the only profit maximizing plan is the trivial plan. If pi little OK equals to Ck of pi, the trivial plan as well as any x1, x2, x3 until xn such that Fk of Z1, Z2, Z3 until Zn times Ck of pi equals to the summations of pi j Zj, Summing with index j starting from 1 to n is a profit maximizing plan. Each consumer is identical to the one in the exchange model. She has an initial endowment Wi in R plus to the n and a utility function ui, which we now assume to be homogeneous. An equilibrium is a price vector pi equals to pi 1, pi 2, pi 3 until pi n, in which there is a bundle xi equals to xi1, xi2 until xin in R plus to the n of goods for each trader I, and a bundle zk equals to zk1, zk2 until zkn in R plus to the n for each producer k, such that the following three conditions hold. 1. For each firm k, profit maximization is well defined at pi, and the input zk equals to zk1, zk2 until zkn, and output q k little ok equals to fk of zk1, zk2 until zkn is a profit maximizing plan. 2. For each consumer I, the vector xi is her demand at price pi. And 3. For each good j, the total demand is no more than the total supply, i.e. the market clears. That is, the summations of xij summing for oi plus the summations of zkj summing for ok is less than or equals to the summations of wij summing for oi plus the summations of qkj summing for ok, such that j equals to little ok. Note that the requirement 1 means that there is no feasible plan that makes positive profit. This rules out the trivial approach of ignoring the production units and computing an equilibrium for the resulting exchange model. We now derive a convex program for certain kinds of utility and the production functions. We first transform the economy M into an economy M prime with M consumers, M plus M goods, and L plus M producers. For each consumer I, an additional good, which will be the M plus ith good, is added. The new utility function of the ith consumer is ui prime of x1, x2, x3 until xn plus m, which is equals to xn plus I. That is, the ith consumer wants only good m plus I. The new initial endowment wi prime is the same as the old one. That is, wij prime equals to the wij if j is less than or equals to n, and wij prime equals to 0 if j is greater than n. The first L producers stay the same. That is, for k which is less than or equals to L, the kth producer outputs good little ok using the technology described by the function fk prime of z1, z2, z3 until zn plus m, which is equals to fk of z1, z2, z3 until zn. For 1 less than or equals to I less than or equals to m, the L plus I, the producer, outputs good m plus I using the technology described by the function f L plus I prime of z1, z2, z3 until zn plus m, which is equals to ui of z1, z2, z3 until zn. It can be shown that there is a one-to-one correspondence between the equilibria of m and m prime. We will therefore focus on characterizing the equilibria of m prime. The simplicity of its consumption side will be of considerable help in this task.